Our math journey continues. We're still in number theory, but today we're actually getting into our fractions. We are working with equivalent fractions. Now, we know that a fraction names a part out of a whole, and we know that our wholes have to be the same size. So I could take this circle and I could divide it into two pieces, and that represents my denominator. And I colored in one out of those two pieces. That represents my numerator. But I could take that same circle and I don't need to divide it into two pieces. I might divide it into four pieces. Well, that means I've changed my denominator from 2 to 4, but I've colored in 2 out of those 4 pieces. That's my new numerator. But notice, both are the exact same amount. Those are called equivalent fractions. Therefore, 1/2 and 2/4 have to be equal. They mean the same amount. Now, we know that fractions always have to be written in simplest form. And the way that we know a fraction is in simplest form is if we take a look at the factors of the numerator and the factors of the denominator. And if the only common factor that they have is 1, then we know that fraction is in simplest form or lowest terms. Now, not all fractions are always in simplest form. So if we take a look at 3/6, yes, they have a common factor of 1, but they also have a common factor of 3. And in order for us to reduce that fraction into simplest form, I would want to take the numerator and divide it by 3. I would take the denominator and divide it by 3. And once I get that final fraction, notice the only common factor that that fraction has is the factor of 1. Therefore, it's in simplest terms. Now, we want to be able to work with the pre-algebra part of this as well. And so, even though the fractions begin to look more complicated, they still work exactly the same way. So let's write a pretty interesting fraction. Let's say we have something that looks like 3ab squared over 12ac. Well, it works the same way in that I need to make sure that this fraction is in lowest terms. That means the only common factor they can have is 1. Well, it's hard for me to see this, so what I'm going to do is I'm going to break it down to its prime factorization. Now, 3 is already a prime number, so I don't need to do a factor tree to break this one down. So I can write that as 3, and I want to be able to see all the common factors. So I'm not going to use exponents. I'm just going to write any of those variables out using just no exponents, single variables. Now, 12 is not a prime number. So I'm going to go back to my prime factorization trees. And remember, we can start with any two numbers to begin this. So I'm going to start with 2 times 6, and I know that 2 is a prime factor, so I circle it. And I know 6 could be 2 times 3. Both of those are prime numbers, so I circle them. So I'm going to write this out always from smallest to largest. So I have 2 times 2 times 3. Now I want to add in my variables, a times c. So it's this same fraction, I just broke it down to its prime factorization. Now what we want to do is we want to cancel out any common factors that are in the numerator and the denominator. And since everything is down to its prime factorization, it's really easy for me to see common factors. So I can see that 3 and 3 are the same, and I know that 3 divided by 3 is 1. And I can see that a and a are the same. And I don't know what the number is for a, but I know it does represent a number, and they have to be the same number. So any number divided by itself is 1. Now, nothing is going to cancel the b's out. Nothing's going to cancel the c's out. Nothing's going to cancel the 2's out. So now I put it back together. Well, on top, all I have are 2 b's. Therefore, I would write that as b squared because the base times the base is the same, and there's 2 of them. On the bottom, I have 2 times 2, which is 4, and I'm going to multiply it by whatever c is So in lowest terms, this complicated fraction can be reduced to b squared over 4c. Now it's your turn to begin this challenge. Are you up for it?